Hi, I'm Ned Nelson from NYTC Noise Stop Systems. Today we're going to talk about echo and reverberation. As you can hear in this space, we've got lots of echo and reverberation going on. So when I'm speaking, it kind of sounds like a toilet. One of the problems with echo and reverberation is that we see in our day-to-day life, in restaurants, in multi-purpose halls, gyms, offices, lots of these different spaces, it turns sound into noise. A noise is basically an unwanted disturbance in our lives. It has the difference of making people stay longer in restaurants to maybe order sweets or to order extra wine, things like that. Or it can have the difference that when you're in a lecture, you can't really focus on what the person's actually trying to communicate to you. It can disrupt meetings, and there's lots of different other problems that can occur. One of the ways that we can understand echo and reverberation better is when we actually measure and quantify what the problem is. One way to do that is by using a computer. Let's just quickly run a test and get that information into the computer, and then we update with the RT, and that basically gives us the RT information. Another way that we can identify is using the clap test. And you can hear the distance and the timeline of how long it takes for that reverberation to die down. That's what we call the RT, the reverberation time. This room has not been acoustically treated, so that's why it's very bad. Let's walk into the office where we're in the process of doing, basically some acoustic work. The environment is completely different. All of that echo's gone, all of that loudness has gone. It's much quieter. We haven't actually finished everything here, but if you look up at the ceiling, we've actually got these acoustic diffusers in place here. This is a fin method. We've also got the suspended diffuser there. If we actually cover them with our polyacoustic sheet, or we use another one of our materials to add on to that, we can even reduce further the problem. Another way that we can determine the reverberation time afterwards is by using another method that we call the clap method. So I've already set it up on a calibration earlier. And that's basically how we measure it that way. So these are all the different ways. You saw the before, you've seen the after, and that's how you deal with it. There's lots of different ways that we can deal with echo and reverberation by using different types of panels, but this methodology that we've used, I've been developing this now for the last 10 years, and it works very effectively. Even with just using timber, by doing the necessary calculations, I've got rid of that unwanted echo, reverberation, the banginess in the room. So let's walk over to the other space again, and you can see. So I'm walking through, and as you can hear, we're getting more and more echo and reverberation, and it's getting more and more apparent, and now we're in that unwanted space again. So then if we go back, this is the before treatment, and then we're starting to walk into an acoustically treated area, and then we're back to peace and quiet again. That's how it works. There are calculations involved. We need to work out what the noise reflection coefficients are, what the noise reduction classes are of the materials, how the sound actually interacts with the space. But once we've done that, we can work out a model, and then we can implement it, as you see here, and we get peace and harmony. Thanks for watching today's little blog, and if you've got any questions, just give me a message below, or you can send us an email, or you can give us a call. Thanks again. See you soon.